Hey everyone and welcome back. I'm David Townsend from the Net Academy, and on this short video what we're going to be covering is the OSPF on Juniper Junos device area range command. We're going to go into how to use it, how to configure it, and what real benefits this command actually brings to the OSPF routing protocol and the routers that are participating in that routing domain. So let's go. And so here's the network for this video. As you can see, it's not a big, sophisticated or large scale network. It's very small, but really just to show the area range command, this is all we need. But what we do see is obviously we've got area 0, the backbone, the transit, and in this area we've got router R0 or R0 and R1, which is an ABR, area border router, which is part of area 0. And then we've got area 1. This is not a special area type. It's not a stub, totally stubby, not so stubby area, or totally not so stubby area. It's just a normal, shall we say, normal OSPF area. And in area 1 we've got routers R1, R2 and R3, and the IP addressing, the connectivity has been tested from router to router, from inside the same subnet, not from subnet to subnet, because we haven't configured OSPF yet. And that's a big point. What we need to do first is configure the OSPF routing protocol, because right now R0 doesn't know about these subnets down here, has absolutely no idea of even area 1's existence, because area 0 hasn't even been configured yet. So that's the first thing we're going to do. And then what we're going to do is go through what R0 is seeing in terms of its OSPF database, but also in its routing table, and this is going to build on that area range command. Right, so I've logged onto VMX0 or R0, and we need to establish the OSPF routing protocol, the adjacency between R0, R1, and within the different routers within area 1, of course. But first things first, let's start with the backbone on R0. So if I just do a quick show protocols OSPF, see if there's anything there configured. There is not. Now that needs to change, so if I do a set protocols OSPF area 0, and I need to add interface gigi 00/1 unit 0 to this, and that's basically it. That's all I want to do on router R0. And if I do a quick commit on that, and in the meantime I will go on to VMX1, and I'll do the same here. If I do a quick show protocols OSPF, again, there's nothing configured. And if I do a now set protocols OSPF area 0 interface gigi 0/0/0.0, and I will also in the meantime do the same thing, but out of the gigi 2 interface, and this will be for area 1. So let me just scroll back. Would have been easier if I deleted it and started all over again. Area 1, and let's also do it out of the gigi 1 interface as well. So if I just do a quick check, show protocols OSPF, and I've already configured area 0 and area 1. So let's commit this now. Now what I should see when I go back onto VMX0 once this has completed on router R1 is that the adjacency should then be established. So if I now do a run show OSPF neighbor, I can see that I've now got that full adjacency from router R0 onto router R1. Great. But this is just really this connection here. I need to build the connection between R1 to R2, R2 to R3, and R3 back to R1. Okay, so that's already done on R1, but now I need to go on to R2. So if I do a quick show protocols OSPF, nothing there. So let's do set protocols OSPF area 1 interface gigi -0/0/2.0, and let's go up again and point it out of .3, do a quick show, make sure I'm happy, and I am. So let's just commit that configuration, and now I'll go on to VMX3 and see if there's anything in the OSPF routing protocol. There's not. Again, as I said, it's completely blank canvas. And let's do set protocols OSPF area 1 interface gigi 0/0/1 1, so this is pointing up to router R1, unit 0, and 3 pointing over to router R2. And I just want to make sure that I am happy with that, and of course I am. Now once this configuration has been built and into the running configuration, they will then have the adjacency. So if I now do a run show OSPF neighbor, and I've now got, and as you can see, I was a little bit impatient, but the actual adjacency was built, so I was a bit concerned. It said two-way here, and I was like, whoa, hang on, I'm not doing designated router and backup designated router. That was the last video. But it was just where OSPF was building its adjacency. So it took a bit of time, but it eventually went from the two-way state into the full state. And if we actually went into the sequence numbers of this, you'd see it wasn't actually that long. I was just being a bit impatient. It's a late night. However, so we've got the OSPF routing protocol, the domain built. But however, can R3 actually ping all the way up to R0? Well, the first question first is, can it actually see in anything in its OSPF database? So if I do a run show OSPF database, let's see what we can see. So I can see everything in area 1. I can see my router LSA, I can see the two network LSAs, the type 2s for this network, and I can see the one summary LSA, that's the type 3 LSA that router R1 is summarizing from area 0 into area 1. So this is the 200.10.20.0 network that is between R0 to R1, and coming back to my original question, I will be able to ping it because it is in my OSPF database, and there we go. So now router R3 can ping all the way up to router R0. However, I did say that we're going to look at a lot from router R0's routing table and its OSPF database. Now if I go onto VMX0 or R0 and run the show OSPF database on here, we can see that actually this all looks good, and this is, as I said, a very small network, but you can really see here that I've got 3 summary addresses. I've got 3 type 3s or summary addresses just from area 1, which the ABR router R1 is summarizing. It's taken all those type 1s and type 2s and summarizing them each into a type 3 summary address, which is why we're seeing these 3 summary LSAs here in the OSPF database on router R0. Now in such a small network, that's not going to be a big deal, but in a larger network where you've got hundreds, maybe thousands of type 3 LSAs, summary LSAs, each one of them is going to take a specific amount of memory up. If there's a link flap or some kind of topology change, you've then got all those CPU cycles which are taken up per router because of the shortest path first algorithm that OSPF uses. It's the Dijkstra algorithm. It uses shortest path first, i.e. what's the shortest path to get to the destination, and it uses link cost to basically calculate what's the shortest distance to get to this actual destination. So this is coming back to the area range command. The area range is basically summarizing all those type 3 LSAs into one summary address. It's summarizing those type 3 LSAs, and that is what I wanted to come on to. Is the big misconception out there with the area range command is that people think it's summarizing routes. It's not. It's summarizing the type 3 LSAs, and that will then have an impact on the routing table, but that OSPF database has to be intact per area, and as such the area range command can only be done on the ABR, on the area border router. It cannot be done on router R2 or R3 because they are not ABRs. It has to be done on router R1. So what we want to do on router R1 is we want to summarize the type 3 LSA for the .4 network, the .8 network, and the .12 network, and we want to summarize that into a single type 3 LSA, and that's what we're going to do right now. And so here is the area range, or the address range, that we are going to use to configure R1, the area border router, 200.10.20.0/28. And again, we are not summarizing routes. we are summarizing type 3 LSAs into a single type 3 LSA. So don't be confused or get a misconception about what the area range actually means. It's not address summarization, it is type 3 LSA summarization. And what we have within this area range itself are contributing routes. And the contributing routes are any routes that fall within this range and are active. And the ones that fall within this range and are active are 200.10.20.4.8.12. How do I know this? You could use any online calculator, or if you like me and prefer to do it in binary, just translate the zeros to ones and you can find out which ones are overlapping and you'll be able to calculate it. Or you can do it quick and easy online. But this is the area range that we're going to do. So here's a before of the OSPF link state database on R0. And if we go into R1 now, we're going to configure this command. So let me go into Edit Protocols OSPF, and we are going to do this in Area 1, because all these Type 3 LSAs that are being sent into Area 0 have come from R1, but Area 1 in the first place. So we need to summarize them at the ABR going into Area 0, i.e. in Area 1 itself. So if we do set Area 1 Area Range 200.10.20.0/28, and I'm not going to do this, but if I then hit a question mark, we've got these really 3 different commands that you can use. So restrict, this is a really cool option. So say any of those contributing routes, if you don't want them to be advertised into Area 0, so you don't want R0 to learn about the 200.10.20.4.8.12, then use the restrict option and it will not be received in its link state database. It just won't be advertised. The override metric is a really great way to actually override the metrics on these type 3 LSAs. So as it gets advertised into a single type 3 LSA, we can actually say, well, if you want to get to this area range, here's an additional metric higher or lower than what it actually may be. So you can manipulate the OSPF cost shortest path first algorithm to decide different routes maybe. Or you can say exact, i.e. any exact address which falls within this subnet, then that will be included. Now I'm not going to do exact or override metric or restrict. I'm just going to leave it like this, and if I just do a quick show, we could see it's now been entered into the candidate configuration. If I hit commit, it should go into the running configuration, and then we're going to go into R0 and see the after and see how has that actually impacted the link state database. So here we go into R0. I'm just going to get a bit of space, and if I run the same command again, and it took a few seconds there. It did take a few seconds there. Again, me being impatient, but we can see before we've got the 3 different summary LSAs, and we have now summarized that into one type 3 LSA 200.10.20.0/28. You don't see the subnet here because this is just high level. You could, however, do show OSPF database LSA ID 200.10.20.0 detail, and now I can see 255.255.255.240, i.e. /28, and it has a metric of 2, i.e. if you want to get to these networks, it's going to cost me 1 to get here, and from R1's perspective it's an additional cost of 1, so a metric of 2. So we've summarized those 3 type 3 LSAs into that one type 3 LSA via the area range command, which is great. But what about those other commands that we saw, and how can they then impact that link state database en route to R0? Well, let's have a look. If I go back onto route to R1, and let's do Edit Protocols OSPF Area 1. Let's do a quick show, and I can still see that area range command there, but there's nothing on the end of it. So let's play about with this area range command and see what happens. So let's first do set area range 200.10.20.0/28, and let's use that restrict command. Is there anything else following that? You can do an override metric, but we'll take it one at a time. So I want to do this restrict command. Now, what impact is that going to have? Well, if we run the commit command, so this goes into the running configuration, then what we should see on router R0's link state database is that actually these the contributing routes are no longer received on router R0. So here's the before as such, and if I now run the same command again, we can now see that that summary command is completely gone. So it was here before that area range 200.10.20.0/28, but as soon as I added the restrict command onto the end of it, it is now no longer prevalent. It's no longer available. It's no longer present on router R0's LSDB. And that is really cool, because if you think about it, what we have basically just said for all these routers, and there's obviously just the one R0, but for all the routers that could be in a backbone or in other areas, we're saying, well, we don't want you to see the connectivity, the IP subnets between R1 to R2, R2 to R3, and R3 back to R1, or whatever it actually may be. So let's go back to router R1 and let's just delete that that command. So I'm just going to delete the restrict option. So let me just do. It would have been quicker again if I went back to the beginning and done it the good old-fashioned way. Let's do show, and we can see it's still there. But now let me go. Let me commit this configuration just so it's back on router R0. And now if I run that same command again, we can now see it's back. But let me now do the same command with the LSA ID 200.10.20.0 detail. What I want to look at is this metric. So now we can see it's got a metric of 2. So it costs me 2. The cost is 2, not 2 hots, but the cost is 2 to get to any of those contributing routes within the 200.10.20.0/28. Now back on VMX1, let's use that override metric command. So let's do set area range, that specific area range, but now we're going to do the override metric question mark, and now I can set this metric to anything from that minimum to that very, very maximum. You can see that is an extremely large number, but if I now set 100 and enter in commit, then what we are going to see on the link state database of R0 is that that metric is suddenly going to increase. And so if I go onto R0 and run, get a little bit of space here, the show OSPF database LSAD, actually if I just push up it would be easier, and there we go. So here's the before, the metric of 2, but it now costs me 100. Now in such a small network, that's not really important, but if you think where you've got multiple ABRs maybe going to the same destination and advertising into area 0 to R0, that they can both reach that same destination, you might want to influence that metric and say, well, to get to that destination via ABR2, i.e. another ABR connecting to area 1, it costs me more to get to that destination via that ABR than it does to go through another ABR. That's how we can influence the SPF algorithm and really the decision process of which route goes into that routing table and thus into the forwarding table, because everything comes from this LSDB in the first place. And that really concludes the end of this video. As I said, it was a short video to show you that area range command on the Juniper Junos devices, how you configure it, the benefits that it brings, and the additional extra configurations you can do, such as the override metric and the restrict option. So the area range is actually very flexible and actually powerful little command that you've got at your disposal. So thanks for watching, and I look forward to next time.